Yes. So is it clear, guys? 5 cases, how errors get combined, in each of these 5 cases. Yes. Sometimes in questions, not sometimes, most of the cases in questions, or we can say in real time situations, yes, we may have to perform more than one operation of physical quantities, isn't it? Suppose, say for example, let z, it is given z is equal to p power a into q power b into r power c. It is given z, the resultant z is equal to the measure of the physical quantity p to the power a into the measure of the physical quantity q to the power b into the measure of physical quantity r to the power c. Here we can say 2 operations are involved, that is power and the next one is multiplication, isn't it? 2 operations are involved, that is power and multiplication. So how do errors get combined? Or how do we find the maximum possible error in the resultant when more than one operation of physical quantities are involved? Yes. Let's see. Here in this case, there are 2 operations are involved. The first one is power and the next one is multiplication. So firstly I am going to consider these individual terms. Alone. Yes. So here, what is the possible error? What is the maximum possible error if it is given z is equal to z1? What is the maximum possible error if it is given z1 is equal to p power a? Yes, it will be del z1 by z1, isn't it? Del z1 by z1 is equal to a into del p by b, isn't it? Del z1 by z is equal to a into del p by p. Is it clear? Yes. Then if suppose it is given z2 is equal to q to the power b, we can say relative error in z2 is equal to b into del q by q. And again, if suppose given z3 is equal to r power c, if it is given z3 is equal to r power c, what is the relative error in z? What is the relative error in the resultant? That is equal to c into del r by r. That is equal to c into del r by r. Is it clear, guys? So relative error in p power a. Relative error in p power a is equal to a into del p by p. What is del z1 by z1? Del z1 by z1 is nothing but relative error in p power a, isn't it? Yes. What is del z2 by z2? Del z2 by z2 is nothing but relative error in q power b, isn't it? Yes. Again, what is del z3 by z3? It is nothing but relative error in r power c. Is it clear, guys? Again, if you are given z is equal to a into b into c. If you are given z is equal to a into b into c, that is, here we are multiplying 3 physical quantities to get the resultant. So what will be the relative error? In the resultant? That is equal to summing up. We simply sum up the relative errors in the individual measurements. We simply sum up, or we simply add up the relative errors in individual measurements, isn't it? Here in this case, here in this given question, instead of a, yes, we are provided with a term with power, isn't it? Yes, here the power of a is 1, or power of b is 1, or power of c is 1. Since the powers are 1, we are not considering those powers, isn't it? Since the power is 1, we are not considering the power value, because we know 1 into any number is equal to that number itself. Here in this particular question, instead of the power 1, we are given with power values a, b and c. Is it clear? So we can can say this p power a is a single term a, this q power b is a single term c, and this r power c is again not here b, let it be b, and this r power b, r power c, a single term c. Is it clear, guys? So how do we find the maximum possible error? How do we find the error in the resultant how do we find the relative error in the resultant when three physical quantities are being multiplied? We simply add up the relative errors in individual measurements. So what is the relative error in the first term p power a? It is nothing but a into del p by p, as if we got it here, isn't it? Yes. Again, what is the relative error in the second term q power b? That is equal to b into del q by q. Is it clear? Again, what is the relative error in the third term r power c? That is equal to c into del r by r. Is it clear, guys? So if you are provided with an equation involving power and multiplication, if you are provided with an equation involving power and multiplication, how do you find the maximum possible error? How do you find the maximum possible error in the resultant? It is given z is equal to, here in this question it is given z is equal to p power a into q power b into c power r power c. So I have to firstly I have to consider these individual terms. Having powers. Yes. So first I have to find the relative error. In these individual terms with power. So what is the relative error in p power a? P power a is equal to a into del p by p. Isn't it? Just now we learned how errors get combined. When there are power values. Yes. So del p by p plus again b into del q by q. Again c del r by r. Again here we are multiplying these three terms. So when we are multiplying two or more physical quantities, the relative error in resultant is equal to nothing but the sum of the relative errors in the individual measurements. Here I found the relative errors in individual measurements. So for finding the relative error in this resultant z, I have to simply add up these individual relative errors. Is it clear, guys? So I got del z by z is equal to a into del p by p plus b into del q by q plus c into del r by r. If suppose you are asked to find what is del z is equal to, then you have to multiply z into del p by p plus b del q by q plus c del r by r plus c del r by r. Then how do you find the value of z? For finding the value of z, you have to simply find what is p power a, what is q power b, and what is r power c, and then you have to multiply the value. So you will get what is z is equal to. Simply multiply these two terms to get what is del z, to get the maximum possible error in the resultant. Is it clear, guys? Yes. Okay. Here in this case there were two operations. Multiplication and power. If the two operations are power and division, let it be q power b. Power and division, it is given z is equal to p power a divided by q power b. So how do we do this? Yes, it's very easy, it's very simple. First we have to consider the terms. The individual terms having powers. So yes, let z1 is equal to p power a and z2 is equal to q power b. How do we find the relative error in z1? Del z1 divided by z1 is equal to a into del P by P. Yes. What is del Z1 by Z1? It is nothing but the relative error in P power A. So relative error in P power A is equal to A del P by P. Is it clear, guys? Yes. Now, the next term is Z2 is equal to Q power B. What is del Z2 divided by Z2? That is equal to B del Q by Q. Is it clear, guys? Error in Q, error in the measurement of Q divided by error in the measurement of Q divided by the actual value of Q. Yes. Now, what is del Z by del Z2 by Z2? It is nothing but relative error in Q power B. Is it clear? So, B into del Q by Q. So here we can say Z is equal to Z1 by Z2, isn't it? Yes, here we can say Z is equal to Z1 by Z2. So when, what is the maximum, or we can say what is the error in the, what is the relative error in the resultant when we are dividing two physical quantities? When we are dividing two physical quantities, the relative error in the resultant is equal to the sum of the relative errors in individual measurement. So here we found the relative error in individual measurements, isn't it? Here we found the relative error in both of these individual measurements. Now for finding the relative error in Z, that is del Z by Z, yes, we have to simply add up these two values. Simply add up these two values. If suppose you are asked to find what is del Z is equal to, then multiply Z and this del B del Q by Q. Yes, once you find the product of these two terms, yes, you can find what is del Z is equal to. Is it clear? Here in this case, how do we find the value of Z? First we will find what is P power A is equal to, then you will find what is Q power B is equal to, then you divide both of these values to get the actual value of resultant. Is it clear, guys? Yes. Now, so here we discussed two combinations, isn't it? That is multiplication and power and multiplication and power and division. So is it clear, guys? Yes. Now let's see the next case. It is given Z is equal to P power A plus Q power B plus R power C. In the previous two cases, the operations involved were power multiplication and division, isn't it? In this case, the operations involved are power and addition. Okay, just like the previous cases, here also I am considering these individual measurements. Yes. So here I am going to assume let Z1 is equal to P power A, let Z2 is equal to Q power B, and let's Z3 is equal to R power C. Z1 is equal to P power A, Z2 is equal to Q power B, and let Z3 is equal to R power C. Now, here the operation involved is power, isn't it? Yes, when we are finding the power of a physical quantity, what is the relative error involved in it? The relative error in the resultant is nothing but power value into relative error of the individual measurement. Now, similarly here also Z2 divided by Z2 is equal to B into del Q by Q. Here also Z3 divided by Z3 is equal to C into del R by R. Is it clear, guys? Up to this, is it clear? Yes. In the previous two cases, that is in multiplication and division, the relative error in the resultant is directly connected to the relative error in the individual measurements, isn't it? But in the case of addition and subtraction, instead of relative error, there the absolute error of individual measurements are connected to the absolute error in individual measurements are connected to the absolute error in the resultant. Is it clear? That is the absolute error, the maximum possible error or the absolute error in the resultant is equal to absolute error in the physical quantity P plus absolute error in the physical quantity Q plus absolute error in the physical quantity R. In the case of multiplication and division, the relative error in Z, the relative error in the resultant is connected to the relative error in each of these terms, that is relative error in P power A, relative error in Q power B and relative error in R power C. Here the case is not multiplication or division, but here the case is addition. As I told, in addition, absolute error of Z is connected to the absolute errors in the individual measurements. Is it clear? Yes. Here we got the relative error. Here we found the relative error in each of these terms. The del Z1 by Z1 is nothing but, or A into del P by P is nothing but the relative error in the individual measurement. So I have to find the absolute error. I have to find the absolute error in the individual measurement. So how do I find the absolute error in individual measurement? What is relative error is equal to? Relative error is equal to nothing but absolute error divided by actual value, isn't it? Absolute error or simply error, whatever it may be, absolute error divided by actual value. So how do we find the absolute error? You have to simply multiply relative error into actual value. Is it clear, guys? So here del Z1 is nothing but the error arising or the absolute error, whatever it may be, and Z1 is the actual value. Z1 is the actual value, and what is Z1 is equal to? Z1 is equal to P power A. Is it clear? Yes. So how do we find del Z1? Del Z1 is equal to Z1 into A into del P by P. What is A into del P by P? A into del P by P is nothing but the relative error in the measurement P power A. Is it clear? Yes. Now, what is Z1? Z1 is the actual value of the physical quantity, and we know Z1 is equal to P power A. So, P power A into del P by P. Is it clear? P power A into del P by P. This is relative error in the physical quantity, and this is the actual value of the physical quantity. And finally I got this is the actual value. This is the actual value of the physical quantity. Thus we found the absolute error in the physical quantity P, that is del Z1 is nothing but absolute error. Is it clear? So how do we find the absolute error in the second term, that is del Z2 is equal to Z2 into B into del Q by Q. So what is Z2? Z2 is equal to Q power B into B into del Q by Q. Similarly, what is del Z3? Del Z3 is equal to Z3 into C into del R by R. Is it clear, guys? Yes. So now what is Z3 is equal to? Z3 is equal to R power C into del R by R. Thus we found the absolute error in these individual measurements. Now it is easy to find the absolute error in Z, that is del Z is equal to, I have to simply add up the absolute error in individual measurement. So the absolute error in the first measurement is P power A into del P by P. So this is the absolute error in the first physical quantity. The absolute error in the next physical quantity Q is equal to Q power B into del Q by Q. Now, what is the absolute error in the third quantity? R power C into del R by R. Is it clear, guys? R power C into del R by R. So what is the maximum possible? What is the maximum possible error in Z in this case? In this case, the maximum possible error in this case is equal to this value. Is it clear, guys? Is it clear guys? Yes. How is it clear guys? Yes. The error involved, or the error, maximum possible error in the resultant when two operations, that is power and addition, is involved. Is it clear? Yes. The same is the case. The same is the case when the operations involved are power and subtraction. Is it clear guys? Yes. For both of the cases, power and addition and power and subtraction, yes, we have to follow this same procedure. Is it clear? Yes. We have to follow this same procedure. Yes. Is it clear guys? All the four cases. What are those four cases? Power and multiplication, power and division, power and addition, then power and subtraction. Yes, we didn't discuss subtraction, but the procedure for finding the maximum possible error in the resultant, in both the cases addition and subtraction are one and the same. Is it clear? You have to follow the same procedure. There is no difference. Is it clear? Yes. Now let's discuss if all of the operations are involved. Say for example, it is given z is equal to p power a q power b divided by r power c into m power y. Again plus, okay, plus or minus. Yes, either plus or minus. Yes. So here I am using plus. The next term is n power d w power x divided by z power u. So you are given z is equal to p power a into q power b divided by r power c into m power y plus n power d into y power x divided by z power u. Yes, here we can see four operations are involved. That is power, multiplication, division and addition. Isn't it? Yes. So the first step is, firstly I am going to consider these two individual terms. First I am going to consider these two individual terms. Yes. So first let's consider this individual term. First let's consider this particular term, and in this particular term I am going to consider each of these individual terms. Is it clear? Yes. First it is given z is equal to so and so. Here we have two terms. Separated by a sign plus. We are adding up these two terms. Yes. So here first I considered each of these two. First I am going to consider these two individual terms as a whole. Now I am going to consider, in this particular term, in the first term I am going to consider each of these individual terms. So and I am going to assume, let z1 is equal to p power a. Let z2 is equal to q power b. Again z3 is equal to r power c. And z4 is equal to m power y. Is it clear? Yes. Now here the operation involved in this individual term, is power. So when the operation involved in the physical quantity is power, then we know the relative error in the resultant is equal to a into del p by p. So here what is del? Z2 by Z2, that is equal to b into del q by q. What is Z3? Z3 is equal to del Z3 del r divided by r. Again, what is del Z4 by Z4? That is equal to y into del m by m. Is it clear guys up to this? Yes. Now here there is a fraction, isn't it? Here there is a fraction. So first I am going to consider this numerator alone. Then I am going to consider this denominator alone. So is it clear guys? Here it is given z is equal to let this be x and let this be y, x plus y. Okay, yes, let z is equal to x plus y. So here I considered x as a term and y as another term. Here I considered this whole value x as a single term, and I considered this whole value y as a single term. Is it clear? Now considering this first term, I considered all the individual values or all the individual terms, that is p power a, q power b, r power c and m power y. Here I observed that in all of these terms the operation involved was power. So I know when the operation involved, or when we are finding the powers of physical quantities, yes, the relative error involved in the resultant is equal to the power value into relative error in the measurement. Yes. So I found I found relative errors in all the measurements. Now again, here I could see, here we can say this first term is in the form of a fraction. Here we can say the first term is in the form of a fraction. So first I am going to consider numerator alone. Then I am going to consider denominator alone. So in numerator we have two terms. In numerator we have two physical quantities, that is p and q. Numerator we have two physical quantities, that is p and q. And here the operation involved is addition. So what, not addition, multiplication. Here the operation involved is multiplication. When we are multiplying two physical quantities, the relative error in the resultant is connected to the relative error in individual measurements. So here I have to consider these two terms. Only, isn't it? Yes. So what is the relative error? Let us assume Z5 is equal to Z1 plus Z2. Let us assume Z5 is equal to Z1 plus Z2. Okay, so what is the relative error? What is the maximum possible relative error in Z5? That is equal to relative error in Z1 plus relative error in Z2. What is Z1 is equal to? Z1 is equal to p power a, Z2 is equal to q power b. And we know the relative error in Z1 is nothing but a into del p by p. And the relative error in Z2 is equal to b into del q by q. Is it clear? Yes. Here not plus multiplication. Yes. Okay. So I found the relative error in the numerator. Is it clear? Yes. Now I am going to consider denominator alone. I am going to consider the two terms in the denominator. So let Z6 is equal to Z3 into Z4. Let Z6 is equal to Z3 into Z4. Yes. Here, what is del 6? What is Z6? Z6 equal to Z3 into Z4. Here the operation involved, or we are multiplying two physical quantities. So when we are multiplying two physical quantities, we know the relative error in the resultant is equal to the sum of the relative errors in individual measurements. So what is the relative error in Z3? C into del R by R plus Y into del M. Y into del M by M. Is it clear, guys? Yes. Is it clear up to this? Yes. Now I am going to consider this whole term. We know Z5 is equal to Z1 into Z2, and Z3 is equal to Z6 is equal to Z3 into Z4. Here, what is Z1 is equal to? Z1 is equal to P power A into Q power B. And what is Z3 is equal to? Z3 is equal to R power C, and Z4 is equal to M power. Z4 is equal to M power Y. So here we can say the first term is equal to nothing but Z5 divided by Z6, isn't it? The first term, we can write the first term as, we can write this P power A into Q power B divided by R power C into M power Y as Z5 by Z5 by Z6. Is it clear? Yes. Here we are dividing these two physical quantities. Here we are dividing these two quantities, Z5 and Z6. So, Z is equal to Z5 by Z6. Z is equal to Z5 by Z6. Here we are dividing to get the resultant, to obtain the resultant. We are dividing these two physical quantities. So when we are dividing two physical quantities, how does the error get combined? The relative error, the maximum possible relative error in the resultant is equal to the sum of relative errors in individual measurements. So we can say del Z divided by Z is equal to del Z5 divided by Z5 plus del Z6 divided by Z6. Is it clear, guys? Yes. Now we have already found what is del 5 by 5 and we have already found what is del 6 by 6. So we have to simply add up all of these terms. Is it clear? Yes. Thus we got the relative error in the first term. Yes. Similarly, by following the same procedure, we could find the relative error in the second term also. Okay, let's see. So I am rubbing up all these. Yes. Here I am writing del Z by Z. Not del Z by Z. A into del P by P, B into del Q by Q, C into del R by R plus Y into del M by M. So this is the relative error. This is the relative error of this whole term, first term. Now I am going to consider the second term. Okay. I am going to find the error. In the second term. Yes. Here let Z1 is equal to n power d, Z2 is equal to w power x, and Z3 is equal to, instead of Z we can write d. Okay, d power u. Okay, d power u, not d, let be f power u. Okay, here I have to find the relative error in Z1. So I got the del n by n. Again, relative error in Z2 is equal to x del w by w, and relative error in Z3 is equal to u del f by f. Is it clear, guys, up to this step? Yes. Now here we can say these two, this particular term is in the form of a fraction, x by y. So now first I am going to consider the numerator alone and then I am going to consider the denominator. Yes. In the numerator there are two terms and we are multiplying those two terms. We are multiplying those two physical quantities. When we are multiplying two physical quantities, the error in the resultant, the relative error in the resultant is nothing but the sum of the relative errors in individual measurements. Let Z3 is equal to Z1 into Z2. Not yes, Z1 into Z2. Yes. Here, what is del Z3 divided by, not Z3, let it be Z4. Yes, Z4. So what is del Z4 divided by Z4? It is nothing but we can say d del n by n, d del by n plus x del w by w. Is it clear, guys? So this is the numerator, and now let's consider denominator. In denominator actually we have only one term. In denominator actually we have only one term. So del z3 by z3 is equal to u into del f by f. Now I am going to consider this whole term. Yes, for obtaining the resultant we are dividing these two terms. So when we are dividing two physical quantities, the relative error in the resultant is nothing but the sum of the individual relative errors, isn't it? So we can say d into del n divided by n plus x into del w by w plus u into del f by f. Is it clear, guys, up to this? Yes. So first we found the relative error in the first term, and then we found the relative error in the second term, separated by the symbol addition. Is it clear? Yes. Now I am going to consider this whole equation. Now till now we were considering, first we considered only this term, then we considered this second term, isn't it? Now I am going to consider this whole equation, and here I observed that I am adding two physical quantities. or I am adding two measurements of physical quantities. Yes. So how does error get combined when we are adding or subtracting two physical quantities? While we are adding or subtracting two physical quantity, the absolute error in the resultant is equal to the sum of the absolute errors in the individual measurements, isn't it? Yes. So far we actually found the relative error in these two measurements. Here so far we actually found the relative error in these two measurements. We have not found the absolute error yet in these measurements, isn't it? Yes. Now the next step is to find the absolute error in the absolute error in this particular term, and then the absolute error in the second term. Then we add both of these absolute errors to find the maximum possible absolute error in the resultant. Is it clear? Yes. Is it clear, guys, why we are finding the absolute error? In these two measurements? Because the operation performed between these two physical quantities is addition. Is it clear? Yes. So now we got let this whole term be A and this whole term be B. Okay, let this whole term be A and this not A, let it be Z1 and Z2. Okay, let it be Z1 and Z2. Let this whole term be Z1 and this whole term be Z2. Here we are adding two physical quantities. We know del Z is equal to del Z1 plus del Z2. Even instead of addition, if you are given subtraction, instead of addition or instead of plus, if you are given minus, there also in such situations or in such cases also you have to follow this same procedure. Is it clear? Yes. So here del Z is equal to del Z1 plus del Z2. So actually so far we found del Z1 by Z1, isn't it? This is what? This is not absolute error in Z1. Actually this is not the absolute error in Z1, but this is the relative error of Z1. And this value is not the absolute error in Z2, but it is the relative error in Z2. So from this I have to calculate the absolute error in Z1 and absolute error in Z2. So del Z1 by Z1 is equal to A into del P by P plus B into del Q by Q plus C into del R by R plus Y into del M by M. This is actually the relative error in the first term. So what is the absolute error in the first term? Absolute error in first term is equal to del Z1 is equal to Z into this whole term. Z into this whole term. Now, what is Z1 is equal to? Z1 is equal to, what is Z1? Z1 is equal to nothing but P power A into Q power B divided by R power C plus M power Y. Is it clear, guys? So, what is del Z1? We can say del Z1 is equal to, I'll write here, P power A into Q power B divided by R power C into M power 1. This is the value of Z1. We just assumed this whole term as Z1. So what is the value of Z1? Value of Z1 is equal to P power A into Q power B divided by R power C into M power Y. Now, what is del Z1? What is del Z1? Del Z1 is equal to, what is the relative error in? What is the relative error in the Z1? Yes, A into del P by P plus B into del Q by Q plus C into del R by R plus Y into del M by M. Okay, is it clear up to this? Yes. So now, what is del Z2 is equal to? It's very easy, guys. Just like del Z1, we have to multiply. We have to multiply the relative error in Z2 by the actual value of Z2. What is the actual value of Z2? Actual value of Z2 is n power d into w power x divided by d power u. This is the actual value of Z2. Now, what is the relative error in Z2? That is equal to d into del n by n, that is equal to d into del n by n plus x into del w by w plus u into del f by f. Thus we got the value of del z. Thus we found the value, maximum possible error in the resultant z. Is it clear? So del z is equal to the absolute error. Del z is equal to the absolute error in the first measurement plus the absolute error in the second measurement. Is it clear? Yes. So how do you find the absolute error in the first measurement and how do you find the absolute error in the second measurement? So I considered these two terms. Actually, I considered these two individual terms. Again in this first term, I considered each of those individual terms having power values. When the operation performed is power, when we are finding the power of a physical quantity, yes, the relative error of the resultant is related to the relative error of the physical quantity. So I found the relative error in each of these terms, P power A, Q power B, R power C and M power Y. Then I observed, when I observed this term, I found that this particular term is in the form of x by y. So first I considered numerator alone, then I considered denominator. So in numerator we are actually multiplying two physical quantities. Again, when we are multiplying two physical quantities, the resultant, the relative error in the resultant is related to the relative errors of individual measurements. So I found the relative error of this term, then I found the relative error of the denominator. Again here I observed that we are dividing these two physical quantities. When we are dividing two physical quantities, again the relative error of resultant is related to the relative error of individual measurement. So I found the relative error of this whole term. Thus I found the relative error of this whole term. I repeated the same procedure in the second term and I found the relative error in the second term. Yes. After finding the relative errors in the individual terms, I noticed that here the operation is not multiplication or division, but here the operation is addition or subtraction, whatever it may be. Here the operation is not multiplication or division, here the operation is addition or subtraction. When we are adding or subtracting two terms, we can say the absolute error in the resultant is related to the absolute errors of individual terms. So here So far actually I calculated the relative error in individual terms. Actually I didn't calculate the absolute error in individual terms. So the next step is to find the absolute error in individual term. How do we find the absolute error in individual term? We know relative error is equal to absolute error by actual value. So to obtain the absolute error, we have to simply multiply the actual value with the relative error. So the actual value of the first term is so and so, and I multiplied the actual value with the relative error of the first term. Again, the actual value of second term is so and so, and I multiplied the relative error of the second term like this. So I found the absolute error of the first term and the absolute error of the second term. Now for obtaining the resultant, now for obtaining the maximum possible error or absolute error in resultant, yes, I have to simply add up those two absolute error values. That is what I did here. Is it clear, guys? Yes, when more than one operations are involved, yes, we have to follow these steps, or we have to follow this procedure for finding how errors get combined. Is it clear? Yes. Here I used variables for solving such problems. Here I used variables for solving these kinds of problems. Yes, in sometimes examinations they give you numerical values. They give you numerical values in the places of these variables. So is it clear? Yes. Combination of error. So now let's discuss some problems on combination of errors. Yes. So we discussed under the topic combination of errors, we discussed 5 individual cases, that is addition, subtraction, multiplication, division and power. Now we discussed when there are more than one operation in an equation. Yes, how does error get combined, or how do errors get combined? We discussed. Is it clear?